I'm going to talk for a bit about the forGL project I've been working on. It's, as I found when interacting with the Haxe Summit coordinators, it's not an easy project to describe. I tried using words that didn't seem to work. So I'm going to do a demo kind of to start with, and then I'll back up and do some boring background stuff. So what I have basically got is a really rough prototype, like I have threatened on the Haxe forum more than once. And so it right now runs as a command line application. And so I'm using Haxe and I'm porting it to 5 different languages. So one of the things you do in Windows to support UTF-8 and international languages, and I'll answer that question on why I'm even messing with international languages later on, is you've got to load something called ANSI-Con, if I can type right. And that will set up support for ANSI escape sequences so that you can do colored text and move the cursor. And then the other thing you need to do on Windows is you change the code page to 65001, which puts in support nominally for UTF-8. And because it's Windows, it's kind of nominal. So I'm just going to go ahead and run the CPP version. And I have 4 of the 5 languages I build run decent. The other one for JavaScript is, I kind of had it to the wiggle and flop stage, but it never really ran right. So the first question is probably near and dear to everybody's heart is, what do I mean when I'm exporting a test verb to another programming language? Well, it's kind of taking the playbook from Haxe. So although this application is written in Haxe, one of the ultimate goals and one of the real takeaways, and I guess you could say value add, is after you use the application, you export what you've done to Haxe source code. And I'd really like to say that's a finished feature now, but it's mostly unfinished and kind of experimental. So I'm going to answer no to this to show you some other stuff. And then I'm not going to show you the internal names either, because we'll get to that later. And I'm not going to show you the details of the various information. I'm not going to show you the details of the words used. I'm going to show you some stacks, though. And we're going to do stack animation a fraction of a second. And right now, because this is dictionary based, it would be good for me to at least give you the mandatory 5-second preview of what a dictionary looks like. So there's the preview. And real quickly, when the dictionary gets imported, you can see here at the top, it has 387 lines and 137 comments because I write comments. So what really happened under the covers was that this forGL application has a built-in internal dictionary. So it builds that up in memory first, and then it imports another dictionary from a file. So if you look at these definitions in the dictionary, and then you look at the text mode for the file, oh boy. Okay, so what we have in the text mode file is I used a open source format called .toml. It's kind of cute. It's Tom's own markup language. It's used for interchange of text data. So it's kind of a replacement for the old style windows.ini files. The idea is to have a text format that's recognizable and you can parse against, but it's also friendly for human reading and also friendly for people to just manually edit the file. So I didn't want to write a big editor along with working on the interpreter for forGL. So I said, fine, a text file input, you can edit words in here. It'll just bring them in when you start the program. So here at the bottom of the file, we actually got some examples that are probably pretty hard to read. Anyhow, some of these examples are words in German. So later on, I'm going to show you, this is like the low-level support that you would put in the dictionary if you were going to port and support any particular language. You'd add the low-level word in German for, I have a built-in verb called show. And so zeigen in German is the German equivalent of the English word show. Okay, so extremely simple translation, so simple I can do it. Then you have all kinds of other words. So you have warend, you have wenn, you have von for from. So we'll get into that a little bit more. Then I tried some other samples, and so what I've got working now that's okay, but it's not great, is I seem to have support for the European style languages. And probably you're still thinking in the back of your mind, why do I even bother with doing all these languages? So that's where I get to the more formal presentation, but first, if I don't show you something running, then all the other stuff you're thinking about is just my imagination, but it actually works. So, of course, my tools are fighting back. So we have a dictionary, and what I do in the dictionary that's built in is I give all the English equivalents for all the common things that you would typically want to have in a programming language. So we have a not equal operator, okay? So in this case, I use some color coding because software developers really like color coding. So for stuff that's built in, I use a green color. You notice that the center column is kind of blank. That's more of a syntactical layer than actually what could be visible to the user. The user has an option to see what the internal representation looks like, so I put that in the column just as a convenience. But you see various words here, and then there's a style that you can do using forGL where the syntax is very forgiving. So having multiple statements per line is no big deal. So right here we have an example of the English version of factorial, and then we have the German version right below it. And the main difference is really cosmetic from the point of view of the forGL interpreter. It says, oh, well, the visible side looks like factorial for English, and it looks like factorial for German. But, you know, they have, you know, other words get substituted. So instead of the word into, it's gate, and so forth. Then I did some other things. I thought I'd do something cute for this before I got kind of so involved with working on trying to fix stuff. And I just declared some simple nouns in different languages, trying to find words with special accents, so I know that I wasn't fooling myself and just accidentally getting combinations of letters that fit the English language. So I'd get, here's one for Spanish, for instance, I think. No, Italian, you're right, Italian. In fact, one thing that would help me as a speaker right now, if you could raise your hand if you have learned English as another language rather than your first language. Okay, great. So I'm not totally lost here on who I'm trying to talk to. So I experimented now a little bit with the more one statement per line formatting. It kind of works, but if you make changes to the dictionary and save them back, I think this gets messed up. Then we have like some standard math functions. And then you can see, so this dictionary is sorted in alphabetical order. So you'll see like standard words, and then you'll see words from other languages just mixed in. And so Okay. So there's another thing that I did. So I wanted to use a verb calling another verb, which is like in programmer speak, code calling other code. And so I just did not only the factorial function, but then the test factorial, which I'm probably not even going to try to pronounce that word. And that's actually kind of an interesting example because it shows off another feature. Okay, so all the math stuff that you see here is pretty much a one-to-one mapping between what Haxe offers as their standard math routines and what you can get at from here. So I'm going to hit a key, and then it's probably not going to display well, but I'm going to try it anyway. So if I want to do something that tests the factorial in German, probably hard to read, but there's a special umlaut character. And what I found out the other day is the input on the, when the user enters a verb is not a really robust code. So here's an example, and to be honest with you, I don't know at this point what's going wrong. I just know that, whoops, the whole U and umlaut just kind of like disappeared from my text. Okay. So this is calling 2 test factorial, which is basically going to get the factorial of 1, which is not exciting, and then the factorial of 2, which is only barely less exciting. But it's done in German, but I just lost the umlaut. You know, that word is not in the dictionary. So I just go ahead and hit enter. And it says, oh, well, it wasn't found. You want to use this one instead. So it does a dictionary search, and it uses a cute little algorithm, and so it finds the closest match of that word. So I'm going to go ahead and say yes and hope that the output looks good. Okay, so the problem is when I load a dictionary and view it, my stack animation is badly out of place. So a lot of this stuff that's visual that a lot of other people would have trouble with is just like, you know, stuff I haven't gotten to. And I've been working more on the insides of the interpreter. So you can see it's animating the stack. And what I've got is I've got 3 different stacks that is at the visible level, and then there's some other stacks that I use internally in the interpreter. So it's basically why this is a stack-based interpreter is because it needs a lot of flexibility to handle different languages. So if you're going to handle language that looks more like a natural language to somebody that's programming, you want it to have the same word order as their natural language, not an artificial word order that a programming language imposes. So because of the animation, it ran pretty slow. You can dial that out and get it to run full speed if you want. I'm going to finish now just so I can refresh and kind of clean things up. So the other thing I'm doing different in this presentation is we're not going to have like a bunch of stuff that me talk about and then nobody asks questions till the end. So is there anything I talked about right now that you have a question about? Okay, I'm going to get into that later on in my presentation, but I thank you for your interest. And to give you the short answer, I spell it forGL and not the number forGL. So when you hear me say forGL, I'm talking about the name of this application, not a generic name for a style of programming. But what's even more confusing, I try to imitate the style of forGL programming within this application. But there are other styles or paradigms, as you want to call them, of programming that I also will add as support. My definition of a generic forGL programming approach is programming that's intended to allow users to do actual programming without having to learn all the gory details that people that practice first, second, and third generation languages do. So let me compare it with Haxe a little bit. So this is a domain-specific language is something that you would typically invent. Like, let's say we're doing an audio application and you want to make it amenable to somebody else. You might have a miniature language that would be all your audio commands, and they'd expect certain data. And then there might be part of those commands where you expect it to have a certain behavior, and you might have modifiers for the command. So, but it's very constrained, right? It's just in this one specific domain. So forGL is not that constrained. I add constraints in a different direction to get as far as I've got now. So I'm just going to finish this. We're going to come back to this later. So I'm going to give you kind of like a big picture on this as soon as I fire up a piece of software, of course. Okay. So I figured one presentation wasn't enough, so I just did two. And so one of them I worked on was kind of like a more detailed slideshow stuff. And then I realized that that's what happens when you know, your power cable doesn't work, and then somebody asks you to do a presentation. Okay. Oh, okay, here we go. So F5. Okay. Now, if anybody can't read that, get a new pair of glasses. Okay, so what we're really after here is, I'm going to talk about the problem space before I talk into the solution space that forGL tries to get into. So we've got many problems. There are many solutions. Some solutions help more than others. Some make more problems. And then we got to think about it. Well, the problems aren't really the solutions, and the solutions aren't really the problems. There's kind of a disconnect between both of them, and they flow back and forth between each other. So the little exclamation point is not because I'm surprised about this. It's my shorthand for saying this is a key idea. So to save space on my slides, I'm putting key ideas as exclamation points. Okay, I'm just warning you ahead of time. I'm not that surprisable a guy. So what is the problem space of forGL? Well, we got 7 billion people. We got over 7 billion phones. So if phones were alive and I was writing bad science fiction movie, you know, the phones would take over from the people. Fortunately, we don't have that. But what we do have is there's a lot of untapped potential in the hardware that's commonly available. There's also, if you count up the different things like all the enthusiast devices and Internet of Things devices and home control devices, I'd say there's easily 1 billion devices that are okay for people to program on. That's not going to cause any problems. It's basically for their own convenience and their. But then, so out of that, so that's a huge pool of talent, a huge pool of devices. So what's missing? Well, we're really missing programmers. And so maybe, you know, this is a guesstimate on my part, but I'd say somewhere around 1% of the population does, say, let's say the limit is 5 to 10 hours of programming a week. It's a very modest limit, but that's about it. So the other analogy I like to use is who's driving and who's the riders. So we're all in this big vehicle. We have the ability to use our digital minions to, do stuff we want. Everyone else offers advice to programmers without trying to sound too radical. That includes people that give you test feedback or say, why did you do this? And so in some ways, programmers are ultimately responsible. So there's actually a new trend that's going on now about ethical programming. And I very much support that idea. So what's the essence of programming really about? There's this wonderful book. It's called The Pragmatic Programmer. I would recommend it for anybody that is a paid programmer to get that book, or at least read it electronically or do something with it. But the point they make, the authors make, I think there was a separate blog post that they did. Programming is not about writing code. It's not about a lot of things. It's a wide spectrum of activities. And if you want to consider yourself as a successful programmer, or even one level above that as a software developer, then you have to really approach it from a learning and communication point of view. And so this ties in with lots of other talks that we've heard recently about what are your real goals? What do you want to accomplish here? So I know one of the things that I'm accomplishing personally is I am well on my way to making a profound number of mistakes with forGL. So we all make mistakes, but I have learned a way to program a computer to make thousands of mistakes per second. So a lot of times you'll hear people talk about their experience, and they'll talk about some cool technology that they worked with. And I'm as guilty of that as at least any 2 or 3 other people in this room. Or other things. But what we really need to talk about is, I forgot to make sure that my allocations and deallocations were symmetric when I was writing this code, or that, the whole program crashed because somebody disconnected the network connection, or whatever the case may be. So no matter how hard we try, and this point's been made over and over again, we're either going to be mistakes that are just because of our lack of knowledge and experience, or we're going to be making mistakes because programming is really a model. And when the programs start running on real machines, then it's the model meeting reality. And then sometimes you get the surprises because reality is what it is, and the programs sometimes don't accept that well. So part of what my talk is about forGL is I'm going to share some of my mistakes with you. So then we come to, if the essence of programming is about learning and communication, then really what's communication? So I write these really simple statements down, and it looks like I'm really surprised to make them, but you have to realize these are key points. So this is what's happening when we're reading this in English. So those of you in the room whose English is your second language, I have enormous respect for you. No way could I learn the language you learned to start with half as well as you learned English now. So the best attempt I can do is write really bad English with grammar errors and capitalization random and the whole thing. So then we have to look at what's the essence of languages. So that's the whole point. We've got roughly about 100 plus major languages on the planet, and probably thousands, if not tens of thousands or more dialects of various languages. I mean, there's lots of examples where you're in a country and you go to a different part of the country and They kind of speak the same language, but it sounds completely different. If you're trying to learn the language, it's like the guy that was in my German class. He spoke German with a Bronx accent, you know, and okay, but you know, it's not what you would normally find. So the whole point about language is we have to communicate. And so the fundamental fact here is this isn't limited to human languages. Programming languages are exactly in the same model. Okay. So part of what I did in preparation for working on the forGL project is I took some time and I spent about a year doing research, and the original idea behind forGL is not mine. It's an imitation of work that I did at a company in the late 80s and 90s. So one of the cool sites that I did find that I thought might help you guys, there's a website called the History of Programming Languages. So I think it's hopl.org. They have over 8,000 programming languages cataloged with a giant sort of a family tree, but they have other ways of getting the information. So if you ever want to learn more about languages outside of Haxe and the target languages of Haxe, that would be something to give you kind of a broader perspective on. But to be honest, if I go on that website now, I might not come back for an hour or two. But programming languages basically have the same purpose as any kind of human natural language. It has to communicate. If it's not a good communication, well, okay. You can do a language that only 2 people on the planet know about, but that's about all they, you know, that's it. Those 2 and maybe the compiler or the interpreter. So it's, what's the real difference then? Well, the real difference is that now we're talking to computers, and all the progress that we made on the hardware side, the software side's really kind of sadly lacked. And our talking with computers isn't a whole lot better than it was in the 50s and 60s. The other kind of a big struggle for people is all the major programming languages, you must know English. You don't have to know the full English language, but you have to know enough to at least read descriptions of application programming interfaces. And usually you have to read descriptions from the tools that you get for free with that language. And there's a whole bunch of baggage, and it's all related to English because that's the language that the programming language originated in. But it's not really a requirement to use the programming language. So now, a little bit about DSLs. We design a language when we want to communicate with programmers or users. So in this case, I'm using a broad definition. I'm not saying it's a really big language. I'm saying it's more like a tiny language. So it might be just an API interface. It might be the label of a button on a GUI with an expected behavior because you labeled it like the word show, so you expect something to show up when you hit that button. So again, programming is about learning and communication. This is a communication side of programming. And another way, the communication side that some programmers don't care for, I've kind of had the experience that if you don't do docs kind of alongside doing the programming, then you get into this weird crunch mode where now we got to do the docs. It should be kind of, from a management point of view, you should shift that left as far as possible and do docs even before you start doing the coding, because then it might help you find logical errors that you can avoid and not put the investment in the coding for. So how to learn and use a major programming language. Okay, so here's the 4 really broad steps. and some more weird notation from me because I don't have enough weird notation to give you. I had to invent some more for this presentation. So you hear about a programming language. That sounds pretty cool. Okay, let's look at the sample code. Uh-oh, it's written in a language I don't understand. So that's why I say TE question mark. So somebody has to put in time and effort if they don't know English. Then we follow the download and install directions up, usually in English. Now sometimes those get translated into other languages, I don't know. I imagine you guys could tell me better than that. There might be like Chinese or French versions of how to download and install Haxe. Okay. Maybe not. Okay. Yeah, or YouTube videos. You know, somebody would just talk about it on YouTube and go through it. So then, this is what a lot of people that already understand English kind of gloss over. Well, these first three steps are just, you know, boop, boop, boop. And then number 4 is where we spend all the time and effort, right? We're running change sample code. So we get our feet wet with the new language. Then we write some new code, probably modified sample code to start with. Then we think about it some more. Then we write some new code of our own. Then we play around with some features. We try to add some combinations. Okay. So, back to the original kind of problem space description. Why are there so few programmers in the world? Well, really part of it is the distribution. English isn't a really big language as far as population goes. And it could be radically different from how your own natural language approaches things. So what makes sense to describe in English may be difficult to describe in your own language. So that's like 2 different hurdles that somebody coming from another language background has to work with. The other thing that's kind of a hurdle, and it's totally unintentional, I understand that, but it's just a barrier to communication. A lot of open source projects don't have very good documentation. They give you a readme.txt file and then you're expected to read the source code if you have any more questions. That works, but it doesn't work well. And I'm guilty of it too. So my documentation is incomplete on forGL, but I can kind of raise my hand and say, it's a prototype, you were warned. So the documentation will definitely have to come along, but I have other challenges ahead before I get heavy on the documentation side. But again, it's all about time and effort. So sometimes it's a false economy. Different individuals or organizations will make the choice, well, we'll do the programming, we'll do the testing, and then we'll document it, you know, when we get ready to do a beta. And then that kind of works, but what you have to really realize is you want to go through multiple revisions of your docs, just like you go through your test and your programming. And if you don't do that, your quality is going to suffer. You might have something that's technically brilliant, but if people don't understand what you created, then you're going to have a lot of trouble marketing that. Okay, so that's my first background about the what's the problem space. Okay. So, show of hands. Everybody wants to see some more forGL demos, or do you want to see more boring demos? Okay, I got a couple of hands. All right, we'll go with that. Just to let you know, I'm a recovering introvert, so I understand why the rest of you didn't raise your hands. So we're going to run the famous, I can show you the other versions real quick just to make sure it's not vaporware. So we have a C#, we have Java, we have a C++ build, we have a Python build, and then we have a mostly broken JavaScript build that is due mostly to my own faults and the lack of experience with kind of pretty much name your web technology. So I'm pretty much inexperienced with HTML, CSS, and I basically went to Haxe because I figured I could write Haxe code and it would do JavaScript for me. Okay, woohoo! I like that one. So we're going to run the Python code right now. And it's got a little batch file. So then it tells you actually which version of forGL it's built. And can you guys read that okay? Okay. So again, it imports the dictionary. It imported the exact same dictionary that the C++ version did. So it reads that text mode TOML file, builds its own internal dictionary, adds to it. Okay, now it's happy. So I'm not going to export yet. I'm going to tease you and hold off on that feature. Show internal names. I'm going to say yes. I want to see some internal names now. Show details. No, I'm not going to look at that. So some of this stuff is more debugging for me, but I figured if it helps me debug the interpreter, it might help other people understand the weird Haxe code that I wrote for the interpreter. So maybe later on, that will be of use to other people. Let's see. I am going to show the details. No, I'm not. I'm going to skip that. Looking at the dictionary showed the details of words used. It messes up the display. So I'm going to show the stacks running and hopefully the same area, the output. And I'm going to make it a little bit slow. And I'm not going to show the dictionary. So here we get a nice little, I tried to put it as a convenience feature, but it's still a little awkward. So it has a built-in test verb that when you compile the code, and I typically put in like whatever bug I haven't fixed yet as the test verb, and then I can run it. So this is an example of two different paradigms. This is a concatenative paradigm on the left that says 5 show. And then on the right, it says show 7. It's more of a procedural style paradigm. So practically all the programming languages that the major programming languages do this are in the procedural style. We got to put parens around your argument list, okay? We're calling a method in a function member in an object. It's got to have its parens around its argument list. There doesn't seem to be any escape from the parens. So, a while back in 1970, there was a guy named Charles Moore. And some of you may guess that the language he wrote is actually a dictionary-based language, and it's called Forth, F-O-R-T-H. And so that was a key idea that inspired a company that I worked at in the late 80s and 90s to use. And they embellished that idea and made it much more interesting. So I'll go into that kind of at the end if we get there and I don't run out of time. So I'm just going to do a test verb. Let's see what's good to run. Let's do test factorial in the German version, but I told it I want to see the internal names, okay? So let's see if I can do this right. So that's factorial with a K rather than a C like English. Okay, well, all right, I'll use the English one for now. So much for this demo. So it's going through a little bit of, it's like single-stepping debugger with automation. So it's going through one step at a time through the forGL interpreter, and it's doing various operations. So some operations will push values on the data stack, some on the operand or operator stack, whatever you want to call it. And then some, I call nouns. You can call it named data like variables. So one of the things that I had trouble explaining to the Haxe people to allow me to do this presentation was, what's this talk about, like nouns and verbs? You're not talking programming here, are you? Well, actually we are. So, I'm not going to go into that right now. So this is running. You'll just have to take my word for it that it can do simple math up to like trig functions and you know, power functions, absolute value. So basically all the math operators you have in Haxe, there you go, you have it in an interpreter. So maybe I did the animation a little too slow. Okay. Or I used too big a number. Well, we can just kind of like clobber that and take care of it one way or the other. Okay, so much for that one. It will eventually print a little table of factorial numbers, but I don't think we want to waste time waiting for it. So that was the Python version running. You may have noticed that it's very similar to the C++ version. Of course, I forgot to load something. So you get funny characters on the screen if you don't load @ccon on Windows. Yes, yes. So if I figure if I make one of every kind of mistake during this demo, then that will be a good thing because you can see what I do and then don't do that. Okay, I'm going to try the export feature now. Drum roll. Okay, not going to show details. Not going to show details there. I'm going to show some stacks. I'm going to do this stack animation at full speed, which might just blur by. Not going to show the dictionary because it messes up the rest of the display. So I'm just going to say 2, and then the English version, test factorial. And then it asks me for the name of how I'm going to export this verb, okay? Because the goal that I have to finish the feature on is I'm going to generate some Haxe source files. Right now, I take the easy way out and I generate some text output on the screen. So I can at least point to something and say, well, it's getting closer. So I'm just going to call this F1 because I kind of like the name. And so the interpreter also has very good error checking, and so if I do something silly, it will tell me, and evidently I did something silly. So, okay, maybe I'll have to try something else with the export. So before I go into the export, which is kind of a really experimental and incomplete feature, maybe it's better for me to give you some more background about forGL. So I've got a repository that's public now, and then I've also had a few mail threads on the Haxe community forum. So those are your 2 good search keys. And then another resource that I've used in kind of background research for forGL is natural languages and then programming languages both. So then I've got a standard disclaimer. When you write an application that kind of looks like a programming language, it's confusing to people. I'm trying to be less confusing. I'm saying it's not a programming language, but it may act like one at times. And the reason I say that is actually a couple different reasons. A lot of programming languages, when they kind of like carve out their territory in the whole programming language continuum, they say, okay, we have a convention, and here it is. And part of the convention is, and if you see a file with this particular file extension, you know it's one of our programs. So .hx, for example, or .cpp, or whatever the programming language may be. At this point in the festivities for the forGL application, I don't see a big need to carve out a separate file extension. It seems to me kind of presumptuous and silly at the same time. So that's where I kind of act like a programming language, but not quite. The other thing that you typically find with a lot of programming languages is they might define their languages in a fairly formal way. They might use BNF or eBNF or even the PEG representation to express the syntax of their languages. None of that exists for forGL because of how it merges the ideas from natural language, the ideas from mathematics, the ideas from programming languages, and then a few skewed ideas of my own. So, with that disclaimer out of the way, anyone that can type on a computer can learn computer programming. And by a computer, I mean practically anything that's digital, like a phone, you can program on your phone with this product. Not today, but I'm willing to bet by the end of the year, if maybe not a few months from now. That's really basic on how good the JavaScript version becomes. And so I've got other programming languages. You saw a little bit of the proof of concept when I was running a German verb in the interpreter. So then I decided, well, I really need to explain some of the syntax behind programming languages, because when I explained syntax to people on the Haxe forum, they kept asking me questions about, does this really work? And, you know, this doesn't look like programming syntax to me, and similar comments to that. So because it allows any mixture of the prefix, postfix, infix notation, why did I go to all that trouble in the first place? Well, it's because later on in the slides, it will talk about our 100+ major human languages have a lot of variation in them. And so the word order for one language sounds really weird in another language. So that's another step I'll get to. So I do a couple examples in it. Of course, you know, Mr. Prototype said, no, I'm not going to work with this combination. So I found when I just tried to jam characters together, kind of like lazy C programmers do, they just say, well, we don't need no white space, you know, we'll just, the interpreter, the compiler can deal with that. Well, this interpreter kind of choked. But what it gave you that was kind of interesting, it uses color syntax highlighting on the output of what the interpreter thinks it is. And you can see by the highlighting that the number 5 and then the operator plus kind of got jammed together. And so I've invented a new format for numbers now. And then the multiply operator got parsed correctly, and then also the built-in verb for show got parsed correctly. The other thing that I've got as a kind of a hint is when it actually ran that, the only thing that was left was a number 6 on the data stack. So if you play mental interpreter in your head, and it turns out that a lot of programming, people spend time playing mental interpreter on your head and reading the source code and said, well, I told it to add 2 numbers, how come the sum isn't correct? So in this case, at least you have a visual cue, okay, that this is a boo-boo on the forGL interpreter. So if you actually parse it out, because the plus didn't get used as an operator, all it did was a multiply. And because it's in read order, you read from left to right, as the beginning of the slide says. So it took the 2 and the 3 and multiplied it. That's on the data stack. And the 5 just sat there. And so when it actually shows something, it will show the number 5, which is totally incorrect. And so that's like 3 different ways of showing you that the interpreter did a bad thing, which I figure if you can debug it one way, that's good. If you can debug it 2 or more ways, that's even better. Okay, so there's some references for the Wikipedia. So then I actually look into one of the screens that forGL did. So when I really wanted to look at this bug and I say, okay, so when I say show details of the words used, this is the output that I've abbreviated to fit on the slide. So the big bug is it should be 6 words, but there's only 5. And the other things is it just gives you more information. So I abstracted to fit on the other slide. This is the details that you would typically see inside the forGL interpreter. So this is not only for me working on the interpreter that helps. This is a debug feature that anybody that's trying to write code using forGL will want to look at and see that what they're writing actually gets parsed out correctly by the interpreter, which I'd like to say it's 90% correct, but I don't really have any stats on that. It's just my own personal feeling, so it could be totally biased. So the big takeaway from here is that 5 output looks like an integer and not a string. So here's a structure that I use that actually represents every element on the run stack of the interpreter. Because it's a stack-based interpreter, every visible token, so even if it's something simple like a curly bracket that normally an abstract syntax tree tosses out, I don't use trees in the interpreter. I use a concrete syntax array. So I did the tree thing in the 80s and the 90s, and I'd rather play with arrays now. Maybe I'll go back to trees, but I don't see a strong reason at this point. And as far as, locality or reference and your memory use, arrays are definitely superior to trees. So I'm going to make that argument. It's not a performance thing. It's more of a locality thing. So it's kind of subtle, but what we have is we have 3 representations for an integer. We have the visible token. We have the internal token. Down here we have what type of token is it? Okay, so it says it's an integer type. Then over here we say, well, here's the value for the integer. So what happened? The string 5 plus got stuffed in the visible and internal token, but the integer number 5 got stuffed in the int value, and it told it was an integer, so that's the way it ran. So it kind of did a reasonable fix-up for the 5 plus, and I'm not trying to invent a new math notation here, but I'm really doing some hand-waving and trying to excuse a mistake, which is wrong. So what's the inputs? Anybody got questions so far right now? Okay. All right. So the inputs are natural languages and math. There's details in the slides. What I do that's a key idea in forGL is to simplify the natural language. So the forGL interpreter itself does not do natural language processing as it's commonly described now. What it does is it uses a simplified form of natural language. The simplified form is word definitions in a dictionary, as I showed earlier. So the whole point on using dictionaries is that you're not limited to English now. You can have your dictionary defining your words in any given language, European languages now. Yeah, you can mix the languages. It doesn't care. The order of words is not important, literally. And that's why I use the stack-based interpreter, because it takes whatever order of words you give it, and it basically pushes things on the stack until it hits punctuation and says, well, okay, if we got any verbs to run, now's the time to do it. And if we got any data on the data stack, that's probably what will make the verbs happy. So in your dictionary, you spell it a little bit differently. But there's a visible form and an internal form. In the internal form, they can both go to the same internal word. In the visible form, you can cover 2 different languages, or a dozen, or 100. You want something that looks like the same in 2 different languages, different things. So that is the new context command that will come out in a new release of forGL after it becomes more of a product and not just a rogue application as it is now. Okay, so a really simplified, so the languages get simplified, you put definitions in your dictionary. That's the key takeaway. Okay, what's the natural language complexity that forGL has to deal with? Well, there's some things I can't get rid of just by simplifying it down to a dictionary. You still have to support various word orders. So that's what that is. There's a reference in Wikipedia. There's 6 different major word orders in the languages of the world. The key idea, forGL will do them. The syntax doesn't matter so much, so for punctuation that doesn't matter. Then we got parts of speech. So how did I deal with parts of speech? Well, even English has about 8 that are readily identified and about 20 if you really get into it, which was starting to make my brain turn to oatmeal. So Greek has thousands, so I said, that's it. I'm not even going to try to go down that road. It's nouns and verbs. And then I'll give you operators from math, and I'll give you punctuation. With that, you can do a lot with programming. But what you have to do is you have to move back. You don't want to use syntax like you use in other programming languages. You want to think about it at a higher level. You want to think about your concepts and how you're defining your words, and try to do programming at a higher level. So actually, Charles Moore wrote a whole book after he had worked on the 4th programming language about problem. It was kind of like a problem-oriented language approach, where you define your problem with your language, and then that leads you to the solution. So that, in a lot of respects, is a dictionary-based approach. So I talk a little bit about problems that I'm going to have pretty soon, about parsing left to right and right to left. Punctuation, I'm not sure. I think some languages don't even use punctuation. And then we got math. Okay, math is, well, it's been developed over centuries, and it's illogical, just like other stuff humans do. So you think math is all like logic and straightforward, and that only takes you up to about the high school level. And then like the math reality kicks in, and then as you get more in the notation, you find out, no, mathematicians will use different contexts and completely different fields or knowledge bases of math to mean completely different things, or they might use a different notation to mean the exact same thing, like your question. Okay, so there is a web standard called ASCII math, I think, that tries to approach that and put on web pages. You can type in a simple math equation in text format, and there it is on the web page. Okay, so the key audience of this is actually beginning programmers. You don't have to know English. You don't have to know programming. You just have to be able to think logically and look up words in the dictionary and add more words. So if you can use a dictionary, if you can type on a computer, you can use this program to learn programming. So the other thing I do with it is allow you to experiment with paradigms. Declarative is definitely the way of the future for a lot of different languages, not just this one. And then right now we have the concatenative, which confuses a lot of programmers that have experience, but it fits in more with people that don't have the experience. And then the procedural notation. And then what I want to add is I want to add thread support, and I want to add objects. I'm not real keen on objects right now, but I think if I don't add it, people will complain too much. Okay, so I apologize, but because of the kind of impromptu approach, not all this material is on the website. I have an older version of this presentation, but the other one I showed earlier, I haven't uploaded yet. So maybe between now and end of day tomorrow, I'll have the website updated with more accurate stuff. I guess nobody has tried using it on their own before I did this presentation. Okay. I guess I scared you guys too much saying it was a prototype. Okay. Yeah, well, it's really so the intended audience is to help people learn programming. That's the main thing. You know, have more drivers, fewer passengers. I usually come up with better expressions after I, you know, kind of wander around for a while. So I'm available for questions if you guys want to ask any more questions. I'm kind of unexpectedly on an adrenaline high right now, so. Okay, so now can I jump in ahead in my slides? Okay. Right. But so this avoids all that because you're not building a knowledge base. You're building a dictionary, and every entry in the dictionary is going to say this is an operator, this is a noun, this is a verb. So it's already disambiguated for the computer. No, it's not, because it's not. So it's not a general purpose forGL. What it is it's language independent on the back because it exports to Haxe real soon now. It's language independent on the front because you don't have to be limited to English. So if you thought of a forGL with really flexible syntax that was fully internationalized for the different world's languages, then you'd be more in the problem space of what this is doing. Okay. So let me give you a tidbit on how this idea came about. Yeah, you guys can take off, you know. Yeah. If okay, well, thanks for your attention.